Welcome back to Hardware Unboxed. Now, recently I checked out 10 of the more entry-level Intel B660 motherboards priced at or below $140 US. And of those boards, the MSI Pro B660M-A was by far the best performer, but it was also one of the more expensive models as well, coming in at $140 for the non-Wi-Fi version. The cheaper alternatives all had issues, unfortunately, and that made them less than ideal. The only real alternative was the Gigabyte B660M DS3H or D3H, both of which suffered from very weak performing VRMs that heavily limited CPU performance beyond the Core i5-12400, and therefore didn't really offer much of an upgrade path. They do offer solid feature sets though, so if you require up to Core i5-12400 performance, and for whatever reason never plan on any future upgrades, then they are viable options, but really not worth saving the $20 on in my opinion. So that's the budget boards in a nutshell. Now it's time to explore more expensive options. We have 8 more models to check out, and we'll start by briefly going over each board and then jump into the test system setup and results. As a side note, I don't have a single ASRock board to feature in this roundup. Really the only candidate would be the B660 Steel Legend, but it's not available here in Australia or anywhere else that I checked for that matter. Unfortunately, ASRock blacklisted us back in 2020 along with a few other media outlets for honest reporting of their products, so we aren't able to get a sample directly from them for testing. I know a lot of you have requested the Steel Legend, so I just wanted to let you know why we won't be covering it. In the absence of any real testing, I recommend avoiding that product until someone can actually look at it. Okay, let's take a look at the boards we do have. Starting with the Asus Prime B660 Plus D4, this board retails for $150 US, so the same price as the Wi-Fi version of the MSI Pro B660M-A. This is an ATX board, but really you're not getting much in the way of additional features when compared to the cheaper M-ATX models. The PCIe slots are much the same, the only noteworthy addition being an extra M.2 slot, though it is limited to ×2 bandwidth. Has to be said, the I/O panel, it's not particularly impressive. You get 2 USB 3.2 Gen 2 ports, a Gen 1 port, and a USB 3.2 Gen 2 Type-C. There's 2 USB 2.0 ports, 2.5 gigabit LAN, an HDMI output, DisplayPort output, and that's about it in terms of connectivity worth mentioning. Of course, what we're most interested in for this content is the VRM, and I'm happy to report that we have full heatsink coverage with this board, though really you'd hope so at this price point. The VRM itself, it's not amazing. It's a 6-phase V-core using on-semi MOSFETs. On the high side, we have 2 4C10B FETs, and on the low side, 4 4C 6B FETs, and that is per phase. This is only a slight improvement over the much cheaper B660M-K, though the Prime gets an extra FET on the low side, and heatsinks covering all of the VRM components, so that should help a lot. Not an amazing board at this price point, it has to be said, but it should work well enough. Now, the Tough Gaming B660M-E D4 is a board that Asus didn't want to provide us, instead opting for the Tough Gaming B660M-Plus Wi-Fi. But the B660ME costs $206 AUD, while the B660M Plus Wi-Fi is quite a bit more expensive at $320 AUD. And I'm quoting Australian pricing as the B660M-E doesn't appear to be on sale in the US yet, though I believe it will come in for around $160 US. As the price would suggest, the Tough Gaming B660M-A is very much a discount model when compared to the B660M Plus Wi-Fi. For starters, you don't get Wi-Fi, it's missing a VRM heatsink, only offering half coverage, the pre-installed I/O shield is now gone, and the VRM itself has been heavily downgraded. The V-core portion of the VRM still uses 4 phases, but with doubled up components, and that means there are 2 on-semi 4C10C FETs on the high side, and then 4 4C06B FETs on the low side. This is a similar configuration to that of the Asus Prime B660 Plus D4, you're just getting an extra 2 sets of FETs. Then we have the Tough Gaming B660M Plus Wi-Fi, which is a really impressive looking B660 board, but of course it's also eye-wateringly expensive for a B660 board, priced at $180 US. You get all the bells and whistles though, 2.5 gigabit LAN, Wi-Fi 6, 8 USB ports on the I/O panel, 4 of which are USB 3.2 Gen 2 ports, with an additional Type-C, and you also get a robust VRM. You also get a pre-installed I/O shield with an I/O cover and heatsinks covering the entire VRM. It is a sweet looking board. This time, Asus has gone with a 5-phase V-core using two 50-amp power stages per phase, so again a doubling of components here. The power stage of choice is Vishay SIC654, which, as I noted, has a 50-amp capacity, so this board should be able to tackle even the Core i9 12900K with relative ease. The last board we have to look at from Asus is the ROG Strix B660-A Gaming Wi-Fi D4, and this is an outrageously expensive B660 board priced at $240 US, so well into Z690 territory there. That said, the Z690 version of this board does cost $350 US. There's no denying that this is an excellent looking board though, that's packed with loads of higher quality features. Over on the I/O panel, which of course features a pre-installed I/O shield, you'll find a total of 9 USB ports, 3 USB 3.2 Gen 1 ports with a Type-C, and then 2 USB 3.2 Gen 2 ports, again one of which is a Type-C, and then there are 4 USB 2.0 ports. For audio, you get ROG Supreme FX 7.1 audio using a Realtek's 4080 codec, and for networking, Intel 2.5 gigabit LAN is included along with Wi-Fi 6. Now, for the VRM, the V-core portion is made up of 6 phases with doubled up components, and this time Asus has gone with Alpha and Omega 55-amp power stages, meaning there are 12 of them in total. And all are covered by large aluminium heatsinks, and Asus has also opted to extract heat from the inductors, which is great as it means a lot less heat is dumped into the PCB, so this board should perform exceptionally well in our testing. Now, from Gigabyte, we have just a single board to look at, the B660M Aorus Pro AX, which currently retails for $180 US. So this is an Asus Tough Gaming B660M plus Wi-Fi competitor. Frankly, I much prefer the look and design of the Aorus Pro AX, and more importantly, it is better equipped, especially around at the I/O panel. Here, Gigabyte has managed to squeeze in 10 USB ports. There's a USB 3.2 Gen 2 Type-C port along with the Type-A, 4 USB 3.2 Gen 1 ports, and 4 USB 2.0 ports. Gigabyte has also included Intel 2.5 gigabit LAN, Wi-Fi 6, and an ALC 897 codec. So it's a very well-equipped M-ATX board that looks good and packs some very large VRM heatsinks. And under them, you'll find a 6-phase VRM, again with doubled up components, using onsemi NCP 302155 55-amp power stages. So there's a dozen of them in total. I expect this board to perform very well in our testing. Now, from MSI, we have the B660M Bazooka, and at $160, it's an Asus Tough Gaming B660M-E competitor. The Bazooka is a unique looking board with green heatsinks. It's a bit out there in terms of looks, let's say, just like the Tough Gaming, I suppose. When compared to the Tough Gaming B660M-E, you do get full VRM heatsink coverage and a pre-installed I/O shield. But other than that, they are very similar in terms of features. Having said that though, the VRM quality does differ quite significantly. Whereas the Tough Gaming B660M-E used onsemi 4C 10C FETs on the high side and 16 4C 06B FETs on the low side, the Bazooka on the other hand uses Alpha and Omega MOSFETs. The V-core is configured in 6 phases with doubled up components per phase. Each phase features 2 AON S36308 FETs on the high side and 2 AON S36303 FETs on the low side. So that's a dozen high side and a dozen low side FETs in total. This should see the Bazooka perform better than the Tough Gaming B660M-E, and if it does, it will clearly be the better choice at $160 US. Now for $20 US more, the B660M Mortar becomes an option, and this is yet another really nice looking M-ATX B660 board. This is a Wi-Fi only model, so Wi-Fi 6 support is provided out of the box, along with 2.5 gigabit LAN and plenty of USB ports, 8 in total, and that includes a Type-C. The board itself is littered in heatsinks. There's a large heatsink over the B660 chip, 2 M.2 heat spreaders, and 2 large VRM heatsinks which also extract heat from the inductors. Oh, and the I/O shield comes pre-installed. The VRM on this one is mighty impressive, packing a 6-phase V-core with 2 Renesas ISL 99360 60 amp power stages per phase. So for the V-core, there are a dozen 60 amp power stages. Couple that with the big heatsinks and you have a recipe for a high performance VRM. For those of you after an ATX board at the high end, the MSI B660 Tomahawk Wi-Fi is a solid choice at just $10 more. It's basically a bigger version of the Mortar using the same VRM configuration, same big VRM heatsinks, just with more expansion options and even more USB ports. There's now 3 M.2 slots, up from 2, and all are covered with heatsinks. The all black design also looks very awesome, and this is probably the best looking B660 board we have, at least in my opinion. Now before we get into the graphs, let's talk about the test conditions. For this testing and any future LGA 1700 VRM thermal testing, I've built a dedicated system inside the Corsair iQ 7000X case. Powering it, we have the HX1000 power supply, and for cooling, the Corsair iQ H170i Elite Capelix. The iQ 7000X has been configured with a single rear 140mm exhaust fan and 3 140mm intake fans, so the stock configuration for this case. Then in the top of the case is the H170i 240mm radiator with 3 140mm exhaust fans. This is a pretty high-end configuration, airflow is good, and in a 21-degree room, I'd say this is an optimal setup, which we're going to call standard airflow. But for this testing, I've also included a direct airflow configuration, which includes an additional 120mm fan covering the VRM. This is without question an absolute best case scenario for any system. So unless you're willing to do this, it's not really a realistic configuration, but I wanted to give these budget boards the best chance possible of actually working. Then for recording temperatures, I'm using a digital thermometer with K-type thermocouples, and I'll be reporting the peak rear PCB temperature. Finally, I'm not reporting delta T over ambient, instead I maintain a room temperature of 21 degrees, and to ensure a consistent ambient temperature, a thermocouple is positioned next to the test system. As for the stress test, I'm using Cinebench R23, which has been looped for an hour, at which point I'm reporting the maximum PCB temperature, again recorded using K-type thermocouples, and I'll also be reporting the final Cinebench score. Please note that the score is only for the final pass and not the average of all passes completed over the hour-long loop, so the score might not be that representative of what was seen during heavy throttling, though for the most part it is accurate. So let's get into it. Starting with the Core i9 1200K data, using our standard airflow setup, all boards ran very hot, but thankfully most were able to push the 1200K to its limits, scoring around 27,000 points, so that is a great result for B660 class boards. The MSI Tomahawk was the best performer, followed by the Asus ROG Strix, which I've got to say for the price wasn't that impressive when it came to VRM thermals, only matching MSI's Mortar. The Gigabyte B660M Aorus Pro AX wasn't amazing either, but at least it's priced below $200 US. The Asus Tough Gaming B660M Plus did allow the 1200K to hit peak performance, but it came at the cost of extreme VRM temperatures. The Tough Gaming B660ME wasn't nearly as impressive, dropping performance by 14%, while hitting very high VRM temperatures. Then we have the Asus Prime B660 Plus, which is a bit of a dud at $150 US, it has to be said, heavily limiting the performance of the 1200K with extreme temperatures. This made it much worse than the cheaper MSI Pro B660M-A, for example, which we looked at in the previous video. Now, providing direct airflow with a 120mm fan made a massive difference, especially to the ROG Strix B660-A Gaming, which dropped to just 51 degrees. Meanwhile, MSI's Tomahawk was again impressive, this time peaking at just 55 degrees. We see that under these test conditions, all boards did manage to extract the maximum performance from the 1200K, and the only exception here was the Asus Prime B660 Plus with its out-of-the-box configuration, which does limit power usage. This board comes with a PR1 limit of just 65 watts out of the box, but you can manually remove it. Doing so here saw temperatures rise to 78 degrees, but still the board did get the most out of the Core i9 processor. This is probably the most important test for B660 boards, as the Core i7-12700 is a great high-performance part for these B660 boards, or at the very least a potential upgrade option. Most of the entry-level boards really struggled with this processor, but thankfully these higher-end models work really well, or at least most of them do. In fact, all of them did, with the exception of the Asus Prime B660 Plus, which ran way too hot and throttled the 12700, resulting in around an 11% performance drop. The standout boards here were the MSI Tomahawk, Asus ROG Strix, though it's way more expensive than all other boards tested, the MSI Mortar, Gigabyte Aorus Pro, and MSI Bazooka. The Asus Tough boards also did okay. They certainly passed, but cheaper options from MSI and Gigabyte did run cooler. Now, if you can feed the VRM a good amount of cool air, all boards will handle the Core i7 at 12700 with ease. The higher end boards will run below 50 degrees, while the lesser quality models like the Asus Prime B660 Plus will keep below 70 degrees, if only just. Now, for around 120 to 130 watt loads, these boards all passed, allowing the 12600K to achieve maximum performance, though again, having said that, the Asus Prime B660-Plus was pretty garbage. Meanwhile, the tough gaming B660M-E was also pretty average. Meeting with Asus, you need to spend at least $180 US on a board for solid VRM performance, and that would get you the tough gaming B660M Plus. MSI took top spot with the Tomahawk, which has proven to be a very solid performer in our testing, while the Mortar does well for $180. And the Gigabyte B660M Aorus Pro AX has also proven to be a solid option. Finally, blasting the VRM with air saw them handle the 120 to 130 watt load with ease, and even the Asus boards managed to stay well below 60 degrees. Last up, here's a look at all B660 boards I've tested so far, which is a grand total of 18. I'm just going to take a look at the Core i7 12700 data from our standard airflow test, as I believe this is the most relevant data, as it's about as high end as most will go on these boards, though there is also the Core i9 12900, but I don't have the non-K version of that chip yet. By far and away the best value board here is the MSI Pro B660M-A, which hit just 70 degrees, putting much more expensive boards such as the Tough Gaming Plus and E to shame, as well as the Prime B660 Plus. This data really does reveal just how messy Intel's ecosystem is. We're looking at around a 70% difference between the fastest and slowest B660 boards using a mid-range to high-end CPU. So buying an affordable B660 board that can get the most out of a part like the 12700 for prolonged all-core workloads is certainly very tricky business, and without tests like this, you basically have no idea what works and what doesn't. It really has been shocking to see just how much of a performance difference there is between the various B660 motherboards, and while it shouldn't be all that surprising based on what we've seen previously, it is still kind of mind-blowing that Intel hasn't addressed this issue. Anyway, I won't talk too much about this right now, as I do have a future B660 video in the works using the MSI B660M-E, which will explore this Intel mess in more depth. For now, let's talk more about the boards just tested. The king of the B660 performance hill, at least without going totally stupid on pricing, is the MSI B660 Tomahawk Wi-Fi. It performed exceptionally well in our testing. The MSI Mortar is also a great M-ATX option, as is the Gigabyte B660M Aorus Pro. Beyond that though, it is really hard to get excited about the rest of the pack. The Asus Tough Gaming B660M-E was very subpar in terms of VRM thermals, and the more expensive Tough Gaming B660M Plus didn't exactly wow us either, while the Prime B660 Plus was very weak and not worth buying given the alternatives. Then we have the Asus ROG Strix B660-A gaming Wi-Fi. It certainly worked well enough, but at $240 US, it's $50 more than the Tomahawk, and I don't see it being worth the premium. So MSI really has dominated the B660 roundups, which is great to see, and I'm glad they're taking VRM performance seriously. They've certainly come a long way since the X570 disaster. Lastly, I'd just like to note that if you're only interested in buying something like a Core i5 12400 or perhaps a slower CPU, and have no plans to upgrade, at least without buying a new motherboard, then VRM performance is really a non-issue and not something you need to worry about. Also, if you just happen to be gaming, then it is true that VRM performance is a lot less of a concern, at least now, as it's unlikely your CPU will be maxed out for long periods of time. That said, if you're tossing up between two boards at a similar price point, and both offer the features you're after, but one packs a significantly better VRM, then ideally that's what you're going to go with, as that will afford you a more flexible upgrade path in the future and likely run much cooler now. As a side note, I've seen this argument made a few times now in the comment section of previous B660 VRM videos, and it goes something like this. I'm a gamer, and therefore I'm not going to use all of my CPU, which means VRM thermals don't matter. To me though, that does beg the question, why didn't you get a cheaper CPU? And if the answer is future-proofing, well then, you're going to want a board capable of fully leveraging that CPU in the future. Whatever the argument though, the point here being that by comparing boards in similar price ranges, you can work out which boards offer strong VRM performance. So if all else is equal, it becomes the easy choice. For example, if you had $140 to spend on a B660 board, you'd have the option of boards such as the MSI Pro B660M-A or Asus Prime B660M-A, and based on our VRM thermal data, I know which one of these boards I'd want in my system. Anyway, that is going to do it for part 2 of our B660 VRM thermal testing. And really this does basically conclude all B660 testing with the exception of that MSI B660M-E board, which just arrived, and I want to see if it's as, let's say, garbage as the ASRock B660M HDV. Hopefully it's not. I don't expect it will be based on what we see on paper, but when we put them to test, things can change. So we'll do that soon. And if the board does suck, you can expect us to pay out pretty hard on MSI. So could be an interesting video in the works there. Make sure you subscribe because you're not going to want to miss that one. Also, like this video if you'd like it, because as I said, testing all these boards has been a tremendous undertaking, but I'm quite glad that it's largely behind us now. We can move on to other content. Of course, there will be more VRM testing in the future. So if you want to support content like this and just get some really awesome perks in return, then we do have Floatplane and Patreon. Links for those are in the video description. You get access to monthly live streams to myself, exclusive Discord server, behind the scenes content, and Q&As. So yeah, check that stuff out if you are interested, but if not, perfectly fine. And I would like to thank you for watching this video. I'm your host Steve, and I'll see you again next time.